and we're going to do page 345 or 346. It's giving an example of playing a game that involves rolling a number cube, and it's numbers 1 through 6. And they're saying, what do you think that the next roll will be? If you're talking about an even number, they're saying you could have 2, 4, and 6, right? 2, 4, and 6 would work. And that would be 3 out of 6, which is 1/2. Okay? What is the theoretical probability of rolling a 3? So as you can see, there's only one option out of 6. So you could say 1 out of 6. A multiple of 3 is different though. A multiple of 3 would be like 3. 6 is a multiple. The interesting part of multiples, so we got 1. What is the theoretical probability of rolling a multiple of 3? So there's 2 outcomes, the 3 and the 6. So it would be, instead of 1, 6, we're going to put 2 out of 6 as your opportunity here, because you can get 2 out of 6, which equals 1/3. The options are 3 or 6, right? So there's 2 out of 6, which would be 1/3. What is the theoretical probability of rolling an 8? If you could see here, there is no ability to roll an 8. So the probability is 0 out of 6. Okay, because you always have to write a fraction for probability, so we're making it into a fraction. 2 events that have the same probability. So rolling a 2 and rolling a 5. Right? Because I could roll a 2, I could roll a 5, that both are 1/6 probability. All right, and then what is the sample space when you flip a coin? Was the probability of landing on heads? A probability sample space, you could get heads or tails. And the probability is always 1/2, right? You get heads or tails, 1/2. The set of possible outcomes, heads, tails. All right, on the back, 346. Trevon has 12 socks. They're equal number of blue, black, and white socks. What is the sample space? So a sample space is what are these options? So you could get blue, black, or white socks. Okay, and it says find the theoretical probability that it's going to be blue. So theoretical probability, I'm just going to label this as a sample. Theoretical probability is, well, there's 12 in the whole thing, and then it's split into 3 options that are equal. So that's a division problem. 12 divided by 3 equals 4. So our options, the probability of getting a blue sock, theoretical probability is 4 out of 12 that the sock is blue. All right, and then a bag contains 3 red, 4 blue, 5 purple, 6 white. We've got to add those up. I already know that. So you've got 9 and 9. 9 plus 9 equals 18. Theoretical of drawing each color. So probability red, it's 3 out of 18. Probability blue, it says 4. 4 out of 18. Probability purple equals 5 out of 18. Probability white equals 6 out of 18. So basically just took that number, put it over the total for each of them. Jack performs an experiment and finds that the probability of drawing a purple marble is 1/4. He thinks the theoretical is incorrect. So theoretical is not incorrect. What's wrong with his conclusion is that theoretical and experimental probabilities can be different. They don't have to be the same. It's not, oh, this one must be wrong then. They can be different. All right. So you toss a nickel and a dime. The outcome is heads for the nickel and tails for the dime. So you've got a nickel and a dime. The nickel, you get tails. And the dime, you get heads. What is the sample space for this experiment? Well, these are your options. You could have gotten heads and heads. You could have gotten heads and tails. You could have gotten the opposite, tails, heads. Or you could have gotten two tails. Those were the options that were available to you, right? I always draw it out just so I could see, okay, I would get this, I could get this, I could get these two, or I could get these two. So there were 3 favorable because the outcome is that you want heads. All right, so what is the sample space? We just wrote it, equals sample space. What is the probability of getting at least one head? Well, when we look through, this has one, this has one, this has one, but that doesn't. So probability of getting at least one head is going to be 3 out of 4. Possibility of getting one head. All right, describe an experiment that has 12 outcomes, and then describe where it would have a theoretical probability of 1/4. Okay, you have 12 marbles. And you choose marble at random. There's 3 black, 3 blue, 3 red, and 3 orange. 3, 6, 9, 12. Yep. What is the probability of choosing red? Okay, well, the probability is 3 out of 12, which can reduce to 1/4. There's your example. And this is going to be for pages 345 to 346.